So this is JEST Physics 2024 Electromagnetic Theory question of part B, and it is of MCQ 3 marks question. Now in this question it is given that an infinitely long cylinder of radius r has uniform volume charge density and a spherical region of radius r is carved out of it as shown in this figure. At what value of r, where r is the radial coordinate in cylindrical system with origin at the center of a sphere, is the electric field maximum? We have to see point P where electric field is maximum. So 4 options are given. Now it is given that it has uniform charge density. So let's assume its radius is, I am taking this as the center, and let's take this radius is capital R and it is given. Assume this charge density is rho, and rho is constant because it is distributed uniformly. Now to get a cavity like situation, because this portion has been removed, we will assume that we have embedded a minus charge density, minus rho charge density of a sphere of radius capital R, so that it has cavity like situation. Now at point P, the electric field will be by applying the superposition theorem. So at point P, we will first calculate the electric field due to uniformly charged cylinder, and then having charge density rho, and then due to uniformly charged sphere having charge density minus rho. So let's take for r greater than r, if we have infinitely long cylinder, so in this case electric field E1 is given by, you can easily derive this using Gauss law, but you have to remember the result. This is rho r square by twice epsilon naught r cap. This is the field due to infinitely long cylinder. Now we will also find due to sphere at same point having charge density rho. So electric field E2 will be given by minus of rho r cube by 3 epsilon naught r square r cap. So now the resultant field due to superposition is given by E is E1 plus E2. We have to take vector sum. So that will be given by, if we take first term as rho r square by 2 epsilon naught r cap minus rho r cube by 3 epsilon naught r square r cap, and this we can write as, if we take rho r square by epsilon naught common, so this will be, we can write this as 1 by r minus of r by 3. So this will be 3 r square, and on this side you have 2 term also, this will be r cap. So we can write the magnitude of the field, that is mod of E, as, just write down the magnitude. So this is rho r square by epsilon naught 1 by 2r minus of r by 3r square. Now, for maxima or minima of E, we will write dE by dr should be 0. So this will be given by rho r square by epsilon naught, and this is minus 1 by 2r square, and this will be plus 2 by 3r by r cube is equal to 0, and this will give you 1 by 2r square, and that will be 2 by 3r by r cube. So if we solve this, we will get r is equal to, this value is 4 by 3r. Now we will check whether at this point electric field will be maxima or minima. So let's check it. So we will calculate the second derivative. So let's find d2e dr2. Take the second derivative. So that will be given by rho r square by epsilon naught, and this will be 1 by r cube minus 2r by r power 4. And we can write this as rho r square by epsilon naught 1 by r cube. Let's take common. So this is 1 minus 2 r by r. And now we have to check this value at r is equal to 4 by 3r. So this will give you E by dr2. So this is rho r square by epsilon naught, and 1 by r cube will give you 27 by 64 r cube, and 1 minus, and from this equation we can write this 2r by small r is 3 by 2. So we can write this as 1 minus 3 by 2. So that will be minus 1 by 2. So this becomes minus 1 by 2 rho r square by epsilon naught 27 by 64 r cube. So overall this value is negative. So at r is equal to 4 by 3r, E is maximum. E is maximum. So now from the given option we can check that option D is correct.